So, in today's video, I'm going to introduce you to functions and hopefully answer the question for you, what is a function? Now, I've seen functions described in many ways, but my favourite way is actually described by this picture here, which I actually took from Wikipedia. And this shows us that functions are like machines. We put something in, the machine does something, the same thing each time, and generates an output that it spits out and gives us. So that's the first comparison I'd like to make. Functions are like machines. We can put numbers into the machine. The machine does something to the numbers, so works with the numbers and spits out another number, or it could of course be the same number. It spits out a result, which is also a number. So you decide what you put in. The function decides what comes out. And this is why our input values, which are more commonly known as x, generally referred to as the independent variable. Because you have choice about what to put in. Then we have our function that creates the output value. And this is known as either f of x, so this is f of x, so the function of x, or it could be known as y, which is sometimes helpful in graphing functions. This is also known then as the dependent variable. So, because it depends on what you put in. So we put in a number, the function works with the number, and it spits out a number that depends on what we've put in. So the function f works like a machine that just changes things in a systematic way each time. So a really important thing to note with functions is that this machine can only be a function. So our operation, oh, let me change that. Our operation can only be a function if for each x value, so each value that we put in, we only get one result. If we had a machine here for which we put in one number and it gave us two numbers as results, then that wouldn't be a function. So a function needs to be a mapping that takes one thing and gives out one thing based on that. So only one result, or y. Now I've said here that we have choice about what we can put in, and that's true to a certain extent. Let's take some examples. So, examples of functions. For most functions, let's say the example f of x is equal to x plus 2. I can choose some x values to put in, and I put them in my function, and they return the function values, or the y values of the function. So if I put in -1, then f of x is -1 plus 2, which is just 1. If I put in 0, I'd have 0 plus 2, which gives me 2. If I put in 100 for x, then f of x is 100 plus 2, which is 102. And this is written as a table of values. An alternative way of writing this, if I say x is equal to -1, then f of -1, so the function as applied to -1, is equal to 1. Similarly, f of 50 is equal to 52. This is an alternative way of writing this. So I could write it in table form, or I could just write it like this by putting in what I want for x between those two brackets. So for this function, I can choose any x value to put into the function, and I always get one y value out. So it works as a function. Every time I put one number in, there's only one possible number I can get out. And this works for any x value that I choose. For some functions, however, this is not always the case. What about if I took the function f of x is equal to 1 over x? Now this works for certain values. I can say that f of -1 is 1 over -1, which is -1. I could say f of 2 is 1 over 2, which is of course a half, or 0.5. What about if I did f of 0? Well, then I'd have 1 over 0, and oh, okay, we know we can't divide by 0, so this doesn't work. So for this one, number 1, we had completely free choice about the x values we put in. However, for this one, we don't have completely free choice because x can't be 0, as we can't divide by 0. So, the set of x values we can put into the function is called the domain. So for this function, we can write the domain as being d is equal to all of the real numbers without 0. And in some books you might see this written as r without 0, like this. These mean exactly the same thing. And let me give you the domain in German. You may have already heard it already. I'll use our green for German colour, as usual. So this one has a slightly restricted domain, in that we can put most real numbers in, but we can't put in 0. So we've talked about all of the possible x values. There is also a term for all of the possible y values. So the set of all y values that can come out of the function is called the range. Put that then on a different line. And again, let me give you the German for that as well. The range is the set of all y values. And this is quite hard to find unless you start graphing the function. And we'll worry about that a little bit later. I just wanted to define some key terms first of all. And you might be asking yourself at this point, now we've defined a few of the different things that we need for functions, and we kind of know what they are. Why do we need functions? And that's hopefully the final question I'll be able to answer in this video. So why do we need functions? Oh, there we go. Why do we need functions? Functions can show us dependencies between quantities and they can help us predict what numbers are going to come out. So for different x values, so they can help us predict the trends shown in patterns. So as an example of this, I found a picture here that shows us some trends. So we have years going along here, and we have numbers going up here, which is actually the number of tons of carbon that each of these countries have released over this time period. And we could see that for China, for example, there is a definite upward trend. And if we approximated this with using a function, then we might be able to say how this trend would continue in the future. So we'd be able to go, for example, to the year 2025 and put that time into our function and see which result comes out. And China would be a reasonably easy one to do because there seems to be quite a clear trend. And the function would then help us predict the future and see as well whether we've got a pattern in terms of the development with China's carbon emissions. The thing to remember, that if you were to do this for yourself, for example, if you ran an experiment in the sciences, then you might come out with a similar graph. For example, you might have time plotted against the amount of plant growth that you've seen, if you were growing a plant in biology, let's say. And then you could approximate this growth using a function. But you always need to remember that there are certain restrictions, that you can't expect, for example, your plant to keep growing indefinitely. And so you might want to restrict your domain to only being within a certain number of days or maybe weeks. Similarly here, for example with China, we might expect that China's growth would continue this way for a little while, but we might hope that, considering the newest climate change deals, China might change its ways a little bit and we might see a drop in carbon emissions from China within a few years' time. So it's always important to remember that any function that we create and that we develop to describe a situation has its limitations and can't show us everything about the situation because it can't predict for future changes, and it can't predict that, for example, your plant that you're growing in biology will stop growing at some point. So we had down here that functions can show us dependencies between quantities, and that's definitely true. And they can help us predict the trends shown in patterns. Absolutely. But it's important to remember that if we model a real-life situation using functions, that these functions have limitations. So hopefully that's answered the question for you of what are functions, and I also hope to be able to show you a few more examples of why we need functions during this unit.